In this video, we learn about the formula for calculating the sum of the interior angles of a polygon. And we'll also be learning about a formula which allows us to calculate the value of the interior angles of regular polygons, like the ones you can already see on the screen here. Now, the formula for the sum of the interior angles of any polygon is shown right here on the screen. And it states that given a polygon, the sum of its interior angles will equal to n minus 2 in parentheses times 180 degrees. And in this formula, n is the number of sides the polygon has. So I'll just say n is the number of sides. So with this formula in mind, let's see what the sum of the interior angles are for 3-sided polygons, 4-sided, 5-sided, and 6-sided polygons. And what we'll be seeing here will apply to polygons with more than 6 sides. So 7, 8, 9, 10, and so on and so forth. So let's go ahead. 3-sided polygons, as I'm sure you know, are named triangles. And all triangles, like the one I'm drawing right now, have 3 sides. Indeed, we can even number the sides 1, 2, and 3. Consequently, for a 3-sided polygon, n is equal to 3. And since n equals to 3, when we use this formula, we can state that the sum of the interior angles of a triangle, which I'll just call capital S, will be equal to, in parentheses, n minus 2. So in this case, that will be 3 minus 2, and I'll just quickly write that. That's in parentheses 3 minus 2 times 180 degrees. So 3 minus 2 times 180 degrees. Now 3 minus 2 is equal to 1, so that's 1 times 180 degrees. In other words, the sum of the interior angles of a 3-sided polygon, in other words, the sum of the interior angles of a triangle, must equal to 180 degrees. And I'll go ahead and box that result. There we go. This result will be true for every triangle there is. But when it comes to a regular triangle, which is commonly called equilateral triangle, all of its interior angles and all of its side lengths are equal. And consequently, if we call each of those interior angles A, so we'd have A, and A, then the value of the interior angle of a regular 3-sided polygon would be equal to the sum of the interior angles, so that's equal to 180, divided by the number of angles. So that's 3. And you can go ahead and check, but 180 divided by 3 is equal to 60 degrees. So the interior angles of a regular 3-sided polygon, in other words, the interior angles of an equilateral triangle, are all equal to 60 degrees. And the results we've just seen for triangles, you probably already knew. But what's nice about this formula is that it still applies regardless of how many sides the polygon has. Furthermore, the result we just saw for a regular 3-sided polygon, that is, how to calculate the value of each of its interior angles, which remember will all be equal, will apply to all regular polygons. And before we write a formula for the interior angle of a regular polygon, let me point out that when we divided 180 by 3 here, 3 was the number of interior angles this triangle had. But 3 is also equal to the number of sides this polygon has. And those two numbers will always be the same. So for a 4-sided polygon, there'll be 4 sides and 4 interior angles. For a 5-sided polygon, there'll be 5 sides and 5 interior angles. And as I'm sure you can guess, we could carry on that way. So for every polygon out there, the number of interior angles there are is equal to the number of sides the polygon has. And so with that in mind, when we just wrote that the interior angle of an equilateral triangle is equal to 180 divided by 3, we can think of that as 180 divided by the number of sides there are. And with that in mind, let's go ahead and write the formula for calculating the interior angle of a regular polygon. And in fact, we could add that underneath here for regular polygons. Each interior angle, which we'll just call A, will be such that A is equal to the sum of all the interior angles, which I'm calling capital S here, divided by the number of side lengths. And I'll go ahead and box that result. There we go. Remember, that result applies to regular polygons only. Okay, now with this formula in mind, let's quickly work through the remaining polygons we see here. So for a four-sided polygon, which is commonly called a quadrilateral, we could have something looking like this. We'd have one side, two sides, three sides, and four sides. And again, we could number them. That's 1, 2, 3, and 4. And so n would equal to 4 in this case. And the sum of the interior angles of this four-sided polygon, which again I'll call capital S, well, that will equal to n minus 2. So in this case, that will be 4 minus 2. And I'll just quickly write that. That's in parentheses 4 minus 2 times 180 degrees. So that's times 180 degrees. And since 4 minus 2 is 2, that's 2 times 180 degrees. And you can of course check, but 2 times 180 degrees, well, that's equal to 360 degrees. Done. And I'll go ahead and box that result. And so every single four-sided polygon out there, in other words, every single quadrilateral, is such that the sum of its interior angles will always be equal to 360 degrees. In the case of a regular four-sided polygon, which remember will have equal side lengths and equal interior angles, each of the interior angles, which I'll call A here, will be equal and can be calculated thanks to the formula we wrote here. And so I could quickly calculate what each of those interior angles would equal to. It's equal to S divided by N, so in this case that will be 360 divided by 4. So if I quickly write that, that's 360 degrees divided by 4. And again, you can go ahead and check, but 360 divided by 4 is equal to 90 degrees. And that's the answer. So each of these interior angles is equal to 90 degrees. And since for regular polygons all of the side lengths are equal, you've no doubt recognized this shape. This regular four-sided polygon is a square. We carry on and look at five-sided polygons, which are known as pentagons. Now, the one I've drawn here is a regular pentagon, but not all pentagons are regular. Indeed, I could draw this. I could have one side, two sides, three sides, four sides, and five sides. And of course, I could number those again. That's 1, 2, 3, 4, and 5. So n would be equal to 5. And then the sum of the interior angles of this pentagon can again be found with this formula. And so if I call that sum capital S again, we could state that that must equal to n minus 2 times 180, where n in this case would be equal to 5. So that becomes 5 minus 2 times 180, which equals to 3 times 180. And by all means check, but 3 times 180 is equal to 540. So that's 540 degrees. And so the sum of the interior angles of a pentagon will always add up to 540 degrees. And in the case of a regular pentagon, like the one we see here, all of its sides and all of its interior angles will be equal, and I'm calling those angles A, like so. And using the formula we have here, we can state that each of those interior angles, A, must be equal to the sum of the interior angles, so that's 540, divided by the number of sides it has, so that's 5. So in the case of a regular pentagon, each of the interior angles will equal to 540 divided by 5. And by all means check, but 540 divided by 5 is equal to 108. So that's 108 degrees. And there we go. Finally, moving on to the last example we have here, that is six-sided polygons, which are known as hexagons. And we can see a regular hexagon drawn here, but not all hexagons are regular. Indeed, any six-sided polygon will do. So I could have something like this. I could have one side, two sides, three sides, four sides, five sides, and six sides. There we go. And again, I could number those. Those would be 1, 2, 3, 4, 5, and 6. So the number of sides here, n, will equal to 6. And the sum of the interior angles of a hexagon can once again be found using our formula. And so if I call that sum capital S again, then capital S will be equal to n minus 2 times 180, where n in this case will be equal to 6. So that's 6 minus 2 times 180, which turns into 4 times 180, and by all means check, but 4 times 180, well, that's equal to 720. So that's 720 degrees. And that's the sum of the interior angles of every hexagon out there. Now, in the case of the regular hexagon, all of its side lengths will be equal in length, and all of its interior angles will be equal. And just for the other examples, I'll call each of those interior angles A, and using this formula again, we can state that the interior angle of a regular hexagon will be equal to the sum of the interior angles of a hexagon, so that's 720 degrees. So we'll just write that, that's 720 degrees, divided by the number of sides the polygon has. So in this case, that's 6. So that's 720 divided by 6. And by all means check, but 720 divided by 6 is equal to 120 degrees. And we're done. Using the formula that we've seen here, we can now calculate the sum of the interior angles of any polygon, and we also know how to calculate the value of each of the interior angles of a regular polygon. And all that being said, that's it for this tutorial.